All right, this week we're going to be looking at setting up SSH, and SSH stands for Secure Shell. I have a write-up on it in the Watts FAQ, and I hope that you will go out and take a look at that. Definitely come to lab if you want to talk about it, better understand it, make sure that you're set up correctly. It's actually a little easier to get going with it on the Mac because it uses Bash, but we can set up a Bash Windows with a Windows client in several ways. But I'm going to just try to talk here a little bit more conceptually about this, what it means to use SSH in a client-server model. So SSH Secure Shell is all about being able to connect from one machine to another. And it's how we are able to take action on a machine out in the cloud or anywhere in a Unix system without having to actually go and plug into that machine. We can do it right from our own console. So this client-server model is important, and I want to kind of whiteboard what's going on with it. And so if you think about, we're going to have 3 machines typically in our workflow. And one of them is going to be DigitalOcean. I'll just abbreviate it with DO. The other one is GitHub, where we store our code. And then our local machine. And this could be Mac or Windows, and if it's Windows, we have to do things a little bit differently, but there's plenty of instruction on how to do that. So what's going to happen with SSH, and SSH allows you to log in to another machine by saying, like, just running this program SSH, and let's say I'm the root user at, and say the IP address is 1234. So if I've got it set up, if I've got my SSH key set up correctly, I don't have to enter a password. I just give username and the IP address. And so this is really nice because it's a lot more secure, for one thing. We aren't sending our passwords across the line, and we only have to set it up once. We can reuse this key for multiple servers. I don't have to create a separate key for each server. I can do that, but I don't have to. So what you'll be doing is going onto your local machine, and you will be setting up a key that will end up in the SSH folder underneath your users, your home folder. So you'll have an SSH folder. The dot makes it a hidden folder, so you don't see it unless you use the ls-la. And then you will actually create an IDRSA file, which will be a private file. You won't want to share that. And an idrsa.pub, which is the public key. And if you cat that idrsa pub, you'll see a bunch of kind of text that doesn't make a lot of sense, but that's your public key. And when you copy that key over to a server, so let's say we're up here in the droplet. The droplet is our server container on the DigitalOcean. If we go to the droplets SSH folder, so let's say I'm in root and I go into the SSH, I'm going to find a file called authorized keys. If it's not already created, it'll get created when you do this work. So if I cat this RSA pub, you'll see a bunch of string. I'll see a big long string. I'll copy it into my buffer, and then I will sign on as root, come over, and I will get it into my authorized keys. So authorized keys contains keys from clients that want to be able to SSH over to the droplet. So that creates a connection between local and DigitalOcean. And you'll see that you'll do a similar thing, only we know in GitHub we just go into settings and we do the add key, and we just paste this ID RSA pub into add key, usually give it a name that indicates what device we got it from, just to help keep track of it. So essentially we've done the same thing. We've copied the SSH key over to GitHub. Now, when we want to work on our programs or our files that are in the GitHub repo, we need to actually make a key over here from DigitalOcean. So we've got one from local, and we're going to end up with one from DigitalOcean as well. So you'll go out and you'll actually create under the SSH here, you'll create the ID RSA and the ID RSA pub here. And so what's happening here is that local is a client to DigitalOcean. Local is a client to GitHub. And DigitalOcean is a client to GitHub. But DigitalOcean is a server to local. And GitHub is a server to DigitalOcean and local. So you can see that any machine in the system can act as either a client or a server. And what makes it a client is that we would be SSHing from it to the machine that's acting as a server, and we're able to do that because we've copied the client's key to the server's authorized key. One other file that you'll see is the known hosts. And so the first time that you SSH to a server, you'll get a question saying, does this server look like something you really want to be connecting to? And if, as a client, you say yes, a key from the server gets written into the client. So in here, I would get a key from DigitalOcean. And that's the client's way of protecting itself against going to a server that it shouldn't be going to. So you'll see in clients, you will see the known host. In servers, you'll see the authorized keys file. And when DigitalOcean acts as a client to GitHub, it ends up with both. So you would end up seeing a known host and an authorized keys. So any machine can act as either a client or a server. And what makes it a client is when it is the one SSHing to the server, to the other machine. So I hope this kind of thinking, this kind of conceptually helps you, because you will be, having machines talk to each other in different ways. And you definitely want to have kind of an idea in mind about who's talking to who, and who's providing resources and who's using resources. And the one providing resources is the server, and the one using resources is the client. And the client, in order to SSH, needs to supply an SSH key to the server. So I hope this is just a little discussion helps you to kind of better visualize what's going on there. And then I would definitely take a look at some of these documents you can see right here that describe how to set it up. And now that you've seen the kind of concepts behind it, I hope that helps. All right, that's it.